Hi, Assalamualaikum. Let's continue with the last mechanism to minimize photorespiration that occur in CAM plant. Okay, so this CAM plant is referred to granulation acid metabolism. Okay, example of plant is cactus and also pineapple. So as I said in the first video to describe photophosphorylation, I said that this CAM plant, they are special because the stomata opening occur at night. Okay, and the carbon fixation occurs twice at the same cell, which is mesophyll cell. So remember, the stomata opening at night. Okay, carbon fixation occurs twice in mesophyll cell. Okay, both occur in mesophyll cell, but first carbon fixation occur at night. Second carbon fixation occur during this. Okay, for first and second carbon fixation actually is the same is what happened in C4 pathway. Okay, here is the mechanism. Okay, alright. So here is mesophyll cell and actually both is mesophyll cell. So at night, CAM plant open its stoma. So carbon dioxide from atmosphere enter the mesophyll cell. So first carbon fixation occur where this carbon dioxide is fixed with PEP, phosphoenol pyruvate. This carbon dioxide is fixed with phosphoenol pyruvate. Okay, this reaction is catalyzed by enzyme PEP carboxylase. Okay, so carbon dioxide is filled with phosphoenol pyruvate. Carbon dioxide 1 carbon, phosphoenol pyruvate 3 carbon, forming of 4 carbon molecule oxaloacetate. Reaction catalyzed by PEP carboxylase. So macam juga macam dalam C4 pathway, this enzyme is has highest affinity towards carbon dioxide and no affinity towards oxygen. So what happened is it may fix the phosphoenol pyruvate with carbon dioxide. So, since after oxaloacetate is formed, this oxaloacetate undergo reduction. Oxaloacetate undergo reduction. Okay. So, oxaloacetate receive electron from NADPH. NADPH oxidized to NADP+. So, oxaloacetate convert to malate. Oxaloacetate undergo reduction, receive electron from NADPH. So, oxaloacetate convert to malate. Okay, molecule which has 4 carbon. Then this malate will be stored in a vacuole. Okay, and this is occur at night. First carbon fixation occur at night. Okay. During this, okay, the malate which is stored from the vacuole, it may undergo oxidative decarboxylation. During this, the malate which is been stored in vacuole will undergo oxidative decarboxylation. Malate oxidize, release its electron. So the electron will be accepted by NADP+. Okay, the same thing occur in C4 pathway. And at the same time, this malate undergo decarboxylation. Malate undergo decarboxylation means it will remove one molecule of carbon dioxide. Okay, so this molecule of carbon dioxide may enter Kelvin cycle. This carbon dioxide may enter Kelvin cycle. It cannot release to atmosphere because at this time the stomata is closed. Okay, it cannot release to the atmosphere because during this stomata of CM plant is closed. Okay, so the carbon dioxide release may enter Kelvin cycle. So after malate undergo oxidative decarboxylation, malate will be converted to pyruvate. Malate will be converted to pyruvate. So during this pyruvate will be converted to starch and will be stored in the chloroplast. Pyruvate will be converted to starch and will be stored in the chloroplast. Okay, at night, the starch will be converted back to phosphoenol pyruvate. So the things happen continuously. Okay, so saya terang lagi sekali. This is CAM pathway occur in mesophyll cell, okay, involve two carbon fixation which occur in the same cell but different time. First occur at night, second is during days. So for first carbon fixation at night, CAM plant open its stoma. Carbon dioxide from atmosphere enter mesophyll cell. First carbon fixation occur, okay, when the carbon dioxide is fixed with phosphoenol pyruvate. This phosphoenolpyruvate is formed after starch convert to phosphoenolpyruvate at night. Okay. So at night, starch convert to phosphoenolpyruvate, which is molecule has 3 carbon, and then this phosphoenolpyruvate fixed with carbon dioxide by enzyme PEP carboxylase. So phosphoenolpyruvate convert to oxaloacetate. Molecule has 4 carbon. Oxaloacetate undergo reduction, receive electron from NADPH. That one is not shown here. Okay, so oxaloacetate convert to malate. Malate will be stored in a vacuole. Okay, this is occur at night. During days, malate which stored in the vacuole may undergo oxidative decarboxylation. Malate oxidize, releases electron. The electron received by NADP plus reductase, not shown here. And that at the same time, malate undergo decarboxylation. See here, malate will release one molecule of carbon dioxide. So the malate will be converted to pyruvate, molecule of 3 carbon. Then this pyruvate will be converted in form of starch and will be stored in the chloroplast until night. Okay, because at night the starch will be converted to phosphoenol pyruvate. Okay, so the carbon dioxide released by the malate may enter Kelvin cycle. This carbon dioxide cannot release to atmosphere since the stoma of CM plant is closed during this. So this is the mechanism how to minimize photorespiration in CAM plant. At first, no problem because the enzyme is PEP carboxylase, and at the second carbon fixation, here the concentration of carbon dioxide is high, okay, compared to oxygen. So Rubisco has no choice; it will fix the carbon dioxide with RUBP. Okay, so you can see. Okay, you can see this lah. Okay, the summarize for pathway in C3 plant, C4 and also CAM plant. Okay, for the difference in C3, C4, CAM, as long as you understand the concept, you can do your own table. Okay, to differentiate all these 3 pathway. Okay, thank you.